Hello everyone, I'm Paul and today we're solving problem 2348, number of zero-filled subarrays. This is medium and the logic here is quite simple, so next I will show you my intuition, approach and efficient solution. Our job is simple, we are given an integer array nums and we need to return the number of subarrays filled with 0. So let's say we're given this, and in case you don't know what the subarray is, it's a contiguous sequence of elements. So for example, this is a subarray. This is also a subarray, but we can't form a subarray with 3 and 2 because these elements are not contiguous. So to solve this, we only need to count the number of consecutive zeros. So for example, here we have 2 and here we have 2 also. And once we get each of these counts, we just need to get the amount of subarrays that we have here. And in case you know about combinatorics, there's a simple formula we can use to get this number. Let's say we have this array of size 3, and we are trying to get every combination of 2 elements in this array. And the formula goes like this. NCR is equal to n factorial divided by r factorial times n minus r factorial. So if we apply this formula in this example, 3c2 is equal to 3, meaning we have 3 different ways to combine 2 elements in an array of 3. We can combine this and this, this and this, or this and this. These are the 3 different combinations. Now let's say we have this subarray, so we only have 2 zeros here, and we are trying to get the total number of subarrays here. And the strategy here is the following. We have 2 bounds for each subarray. So for example, we have one subarray that goes from here to here, another subarray goes from here to here, and another one goes from here to here. So for each of these subarrays we are using 2 bounds, left and right bounds. So to get the number of subarrays here, we need to do n plus 1 c2. And we are using n plus 1 because we are not focusing on the values, we are focusing on left and right bounds. So we want to get every combination of 2 bounds in n plus 1 bounds. Here we have 2 elements, so n is 2, and 3c2 is 3. So from 2 consecutive zeros, we can get 3 subarrays. So this is the value we need to add to the result. With this in mind, let's see the full approach now. We are iterating every value in this array from left to right. So we start from here, from index 0. And we will have a variable, we will call this count. This is initially 0. And we will use this to keep track of consecutive zeros. So given that this is 1, we continue with the next element and this stays at 0. Here we have a 3, so we continue. Next we have a 0, so we add 1 to count, this is now 1. Next we have another 0, so count is now 2. Next we have a 2, and when the current value is different from 0, and the count is also different from 0, we need to count subarrays. So here we have 2 consecutive zeros. Meaning now we can use our formula. We can do 2 plus 1 c2, and we know this is 3. So the result is initially 0. And now we need to add this 3 to the result. So the result is now 3. And after adding this to the result, we reset count back to 0. Now we are here and this is a 0, so now the count is 1. Now we have another 0, so this is 2. And finally we have a 4. This is different from 0, so we need to add to the result 2 plus 1 c2. And this is 3. So we add 3 to the result, meaning this is now 6. Now the count is 0 and we end this loop. And given that the count is 0, we return the result, which is 6. If this was not 0 by the time we end this loop, here we will need to add the corresponding amount of subarrays to the result. But given that this is 0, we just return 6 here. So this is it for the approach. Time complexity will be big O of n and space complexity big O of 1. So now let's go with the code and hopefully you will get the idea. First, the result is 0, the count is 0, and we can iterate every number in the array. So for x in nums, and if x is 0, we just add 1 to the count. Now, if the count is different from 0 and the current value is not 0, we need to add subarrays to the result. And in Python, instead of using the formula from a few minutes ago, we can use a function comb. So the first value is n. And remember, we need to use n plus 1 c2. So here we do count plus 1, 2. And now we need to reset count back to 0. And finally, if the count is different from 0, we need to add to the result the remaining subarrays we have in count. So here we say comb count plus 1, 2. And finally we return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.